So we're going to look at the RMS signal. We're going to calculate the RMS signal for a sine wave. In power systems, we're using a lot of AC waves, looking at AC power for linear loads and linear systems. And we need to calculate the RMS. This will become a little bit more apparent once we look at power of AC systems. But for now, just remember that RMS is very important. And we're working with sine waves, so we're going to calculate the sine wave RMS value. Okay, so this is the equation. Take your signal, you're going to square it, then you take the average of it, and then you take the square root of that. So this is the basic equation. If we're working with a basic sine wave here, we first need to define x. So what is x? And in this case, we're going to do x of t. We need to define the peak value here. So we're actually going to call this xp, peak, just to make it very clear that peak value here. So it's going to be x peak, and then we're going to multiply that by the sine wave. And here we're working with time rather than angle, so if we're going to do that, then we would have t times 2 pi over the period here. So we're going to say this period 2 pi is t. Of course, this point is 0. And so this is our equation that we're going to work with. So now what we have to do is put that into here and evaluate this expression. Okay, so let's start with x RMS. Take square root of all this and 1 over t. And first we need to square this. So we're going to get x peak squared, and then we're going to have this sine, and it's also squared, and just maintain that value, 2 pi over t. Right, so squared value and then dt, taking the integral of that. Great, so this value is not affected by t, so we're going to move that outside. And then this sine squared that's left, not really that nice to work with. But we can use our handy trig identity, which you can look up in a table, which is a trig identity for sine squared is equal to this value, which is a little bit easier to work with in terms of integrals. So we're going to take that, plug it into there, move that over. So let's do that. So now we have x peak squared over t, and we have the integral from 0 to t of now this value. So we'll get, I'm going to move the 1/2 to the front, then we'll multiply all that by 1 minus cosine of 2 times u. U in this case is this expression. So it's going to be 2 times 2 pi over t. Sorry, big T and little t. You can just look what I'm writing. And then this would be the proper expression. Okay, and now that, we're going to take the integral of that. Okay, we can move out this 1/2 again because that doesn't depend on t, and then we'll go ahead and take the integral of these two values. Okay, so we get x peak squared here over 2t. Then we're going to take the integral. This is just going to be t. So t evaluated at 0 and t minus. Now we have to take the integral of this. So the integral of cosine is going to be sine. We maintain this value in here. We're going to just simplify a bit. And then we have to divide by the derivative of this. So it's going to be 1 over 4 pi. It's going to be over t again, but we can just move that up to the top here. And we'll evaluate that at t and 0. Okay, so now we can evaluate these. Okay, so we have x peak here, squared over 2t. Here, we're going to get t minus 0, which is just t. And we're going to minus, I'm going to move this to the front, so we get t over 4 pi. Now we're going to evaluate the two different values of sine. So we're going to get sine. When we evaluate this at, this at t, we're just going to get 4 pi. So we get sine of 4 pi. And then minus, we evaluate this at 0, so it's going to be sine of 0. Okay, got a lot of brackets here. Okay, so we have now this expression. So it looks a little bit messy, but if you look at these values, here's our sine wave. Sine of 0 is 0. So this is exactly 0. And sine of 4 pi is going to be twice this. So we're going to get back to 0 again. So that actually looks to be very nice. So this whole expression will go to 0. And now we're just left with this. So let's simplify. X peak squared over 2t times just t. So these t's will cancel. And what we'll be left with, if we take the square root, is we'll get x RMS is equal to just x peak here divided by the square root of 2. So this is our very basic equation for relating the RMS and the peak value in a sinusoidal, in a sine wave. So these are the two values for RMS versus peak. Take your peak divided by root 2 and you'll get the RMS value for a sine wave. Okay, hope that shows you how to do the math, and we'll be doing a little bit more of this, so look forward to more.